In the last video, I described how to do the manometer problems, number 1. I left number 2 for you to do. And for number 3, it's asking what do we mean by atmospheric pressure and what causes this pressure. Well, any sentence you write or say about pressure has to involve force, particles, and collisions. So one way to say what we mean by pressure would be to say pressure is the force of gas particles or air particles colliding with a surface. So the greater the number of collisions or the greater of the force of the collisions would increase pressure, and vice versa. The lower the force or the smaller number of collisions would give you a smaller pressure. In the case of atmospheric pressure, we need to talk about gravity. So I threw this picture in here, and I really should have put it in beforehand, but what this picture shows is that the atmosphere is the most dense at sea level and the least dense out as we move towards space. And there's really no defined boundary for space. It's not like Earth has a shell around it. There's just fewer and fewer and fewer particles until there's almost none, or until it's not worth measuring anymore. Number 4, how do we measure atmospheric pressure? Well, we've got to have some kind of tool. One tool we talked about already were manometers, and we went over those problems. There's also such thing as a barometer, and you'll hear about those in weather reports. What we're going to use in class, though, are the Vernier and Pasco electronic sensors. So, is atmospheric pressure the same everywhere on the surface of the Earth? Short answer to that is no. The long answer is that, as we said before, since the particles are most dense of the atmosphere, since the particles of the atmosphere are most dense at sea level, as you move up away from sea level, you get into these parts of the atmosphere where you have much fewer, the best way to say it is far fewer particles. And so if you think about this and you look back at the manometer and you remove the liquid from it, and then instead of thinking about it as a plastic or glass tube connected to a rigid container, if you just think about this as the atmosphere around Everest, and this is like, if you think about this as your lungs and you think about this as a balloon and your lungs are expanding, well, if there's less pressure out here pushing into your lungs, then it doesn't matter if you expand the volume to let air in, it's going to have a tougher time coming in because there's just not as many particles to come and fill up your lungs. And so that's why people take oxygen tanks and other breathing equipment up when they try to climb Mount Everest, so they can continue to breathe even though the air pressure is very low. And it's the same reason that airplanes pressurize their cabins. So when you have one of those airplane disaster movies or some spy movie where some guy gets thrown out of a plane or whatever, often there's those masks that come out if the cabin's breached, and you'll always see pilots of fighter jets and other aircraft that go up high in the atmosphere. They have special breathing equipment up there for the same reason. So that is page 12.